I would create a new project. I have no idea about the design. Probably we will create a student record kind of thing, which we have already been doing. Ultimately, we have to integrate or replace the local storage, which we already created one simple example, which use the local storage for persisting the data. But I really want to replace it with IndexedDB. So I'm going to create a new project, but I'm going to keep the same design. So we will replace the local storage with the IndexedDB. That we will proceed because we really need a UI to verify how things are working. We have already created such a UI. So let me create a new project and then I'll copy paste the old example. Time to do a little cleanup. Before that, that IndexedDB part I'll write here itself. Then I'll copy paste the what you call UI. Two objects you need to create in order to use the IndexedDB. First one, a request object, and another one, a DB object. Remember, these are all user defined objects, but I'm just giving a name in such a way because this object I'm going to use to create a database and also get access to the database. So I'm just creating two global variables. Probably we can initialize here itself. Indexed suggestion won't come most of the time. So IndexedDB, open a database, say mydb.db, any naming convention suitable, and the version. You are creating a request object. You are trying to open a database called a name with a version number supplied. In this case, two possibilities. The database may be existing already or a database may be required to be created. So when a request is made, the request has to be handled in such a way in both the cases whether the database is new or already existing. If at all you receive a request object, when you try to open IndexedDB, the request object will have an object called onSuccess. OnSuccess value is based on the function callback. Remember the value assignment. It's not the object itself is having a callback. So in this case, you will have a function. If a database is successfully opened is possible only when the database is already existing. If not, we have to handle other. This is error. If something goes wrong, we will come back. On upgrade needed. This is one of the important object. This is one of the important object in the request variable. This is where you are going to handle a newly created DB. For example, if a database is already existing, you will get a success call. Of course, the database is already existing. You are opening the database. Or the database is not existing and it is going to be created. You can get a callback over here whenever a database is successfully created. Okay. Then we have to verify whether these things are working or not. So let me put a couple of console statements. me see. Okay, I think probably I can proceed further. First thing, getting from the event target and hope it is result. The database, if it is newly created, it will come here and execute and give you a read access to the database. So you have access to the database. The database is successfully, newly created, and of course the instance of the database you have, and you can perform various object store creation transaction with this object. Or if the database is already existing, you may do in this way. This is one way. Okay. So now we have to see whether these blocks are executed or not. Sorry. There it is. There it went. Here it is. Okay. Mac has excellent feature of maintaining multiple screen. Okay, let me see. Okay, inside on upgrade, this error we don't need to worry about it. So I think it's going, and I have access to the database. Now, when a database is successfully created, you would have to create various object stores. Object store mean tables. So time to create various table or table schemas. Then define what you call, if you really want to preload some data, you can do it here. So a bunch of data, for example, already existing students, if you have some data, you can preload it here, or if you want to restore from somewhere, you can do it. So in this case, we have to do a couple of stuff. First thing, I'm trying to create an object store. DB create object store. Okay. I'm trying to create table. TD TV or whatever. Any name you can give. Here, are you going to maintain any primary keys if you want? If you are maintaining a primary key, there is an object has to be created with a key path. Key path is a reserved word attribute name. So assuming the student table is going to contain various fields: student ID, student name, student subject, what we did. I think these are all the things we kept in the previous example. The same thing I'm just going to proceed. So student ID and student name and student subject. So three fields I'm going to keep inside my table. So in that, the student ID is going to be my unique ID, or which is going to keep what you call primary index or primary key. So I'm just going to make it std ID. So you're trying to make a request to create an object store, and when the object store is successfully created, you will get a callback if you really want to see whether the object store is created or not. So this is a simple way. Remember, object store we will be quite often using. Object store means you are trying to access a table. Object store, there may be multiple object store possible for a given database. In a database you may have more than one table, so you can create as many as object store as many as tables if you want. You can go ahead and create in this way. So not it's pretty clear. I think there is an option to add a primary key. Let me see what's that keyword. So here one more reserved keyword, add auto increment set to true. If you set it, this key will become a numeral primary key, and the values will be automatically assigned. You don't need to give explicitly. Just create an object and insert it, and new ID would be created and will be inserted along with the record. So I'm just trying to make it as a auto increment. This is a pretty basic convention we'll be using quite often. Okay, I'll make this one as a object store itself. Name and I'd like to give an indexing capability to for my rest of the fields also, if you really want. That you can create index. Std name. I'll explain one I done. If you want to give a different name. For example, this particular statement, I am giving indexing capability to my another field, student name, because first thing, once the primary key defined, I need to go ahead and tell how many other fields are existing. That part I need to do. Of course, it is doing it. And also, I am adding the indexing capability to this one. Mean I can execute a query select star from student name equal to something. So if I define that particular field having an indexing capability only, that particular field becomes a queryable string. Otherwise, it cannot be queried. So this part does two things. First thing, it adds a new field along with the objects. To the object store called std table. Already one field has been added, which is called std student ID, and I'm adding a new field, student name, and I am also telling the student name can be queried using this query whenever required, and the student name is not unique. Duplicate name is also accepted. So what we typically give an example, maybe varchar of this value, or it's not unique. I'm defining the field and what kind of capability it has. So this particular part defines field and gives indexing capability. Okay. When I do a simple query, you will get to know it. And I have one more field, I hope. For that, I'll keep the same name. std name, what we call std subject. And I'm defining this is also unique. Okay. By seeing this level, every field has an indexing capability 1. Then you may be wondering what's the use of this having a unique key, primary key separately. Because everything can be individually indexed. If I supply student name equal to some name, it has its own indexing capability, it will find the record. But why I still need a primary key or another field which it could identify the record? Maybe because these two fields, yes, it has an indexing capability, but they are not unique. Sometime I would have to get the exact one single result. But if I maintain student name as an index or student subject as an index, I cannot fetch the required result. There should be something which uniquely identifies the record. That's the reason we have a std separately added. So in this example, yes, we created a table with the 3 fields, in that one field being a primary key, auto increment capability. Of course, it's going to be unique throughout, and additional two fields with still having an indexing capability and having unique property set to false. So we have just created an object store with three different fields. So these object store are nothing but a table as far as a relational database environment. So this particular part handles a particular table being created, database being created, and go ahead and creates a new object store for your further usage. Okay, we'll have to do a simple function. I'll do a simple function. I'll leave you guys for a break because the next part I need to integrate everything, but at least we would like to verify these things are working or not. So up to that we'll finish and then we'll leave it. But at least up to this point, I attempted to create a database. A database, I need to verify it is a newly created one or already existing one. If I just change the database name, you may be noticing because I did a lot of changes here. So I need to force the on upgrade needed to be called, because if it is a new only, it will create a database fields. Because already I ran that example, so that it may be assuming that database is already older, so this block may not be called. So when a very first time you execute and attempt to create a database, an on upgrade callback will happen, and it will also give you access to your database, plus it will create the necessary object store, in this case table. Okay, I'll do a simple stuff like put a couple of buttons. Inside a random record we will do it. I'll write one more function. This function I'm going to do, I'm going to call it to verify whether the add call works. For example, the add will only work if the database is created and the field is being created. I don't have any idea like what is the object store created inside. Instead, what I'm trying to do, I'm trying to insert some value and retrieve it. Okay, if everything is there, I should get back all the values in the object store. Couple of things, of course, I need to create various objects. First object, transaction. Remember, I started doing a transaction using the DB transaction. I'm going to do a transaction. Transaction expect two arguments, one being an array, another being a string. First thing, how many object stores you are trying to call. In this example, I have only one single object store. If you have multiple, you can define separated by comma. Okay. This particular object store I am trying to call. What kind of access you need? Read, write. Because addition is we need a write access. Either you can also call read only access, maybe only to read the content which is already there, but for addition naturally we would need a write access as well. So first you create a transaction object from the DB what you have, then get object store from the transaction. It may be still redundant. Which object store? For example, you may be having a transaction variable with a multiple table read permission. In that you are trying to get one single object store. So if you have multiple tables, you will create two different object store values. So individually. So now you have an object store instance. Now using that I can do for example various things. First thing, let me prepare an object which I am randomly trying to. So a random object. Let me create std name, right? What are all the things? Std name. Okay, instead of same thing, probably what I do, subject, some random values will insert. So this object I'm trying to insert. So object store add random data. In the table, add this data. I need a result, whether they successfully added or not, I need to find out. So let me create an object. You are capturing that into an object called request to insert, something like that. So request on success. If successfully inserted, you will have an event object given as a confirmation. So I'm just going to output it, whether it is doing or not, or what is that event target, what is that we will verify, what kind of event it is giving for me. So the add student record, first prepare a transaction object, and transaction object tells how many fields, how many object store you are trying to get a read or write access, whatever it is. You are defining how many. In this case, only one table we have, just one object store we have, we told, or we have defined it. Okay, now you prepare object store instance or table instance. Which object store in that, which you have a read write access, which object store you are trying to retrieve. I'm telling, okay, this is the object store I'm trying to retrieve. Now, what in this example, this function is going to do an addition. So the object store is going to add a new data. So this random data I just kept it. Probably we in the UI we let the user to type something. When the user click on submit, we will get this object. But for the testing purpose, I just created a simple object. And object store add, I'm trying to add it. It will give you an object. That object will have a method on success. That success will have a value if a object insertion goes successfully. We'll have to verify this. Okay, I have already called it. Is there anything else? Okay, just open here only. Okay, just refresh. Assuming the data is successfully created. Okay, now I am trying to insert something. It gives me a couple of things. Okay, I'll do one thing. I'll just see there is a result object which is giving a substantial information. Event target result. So notice when I keep entering it, looks like some new data is being added and gives me a primary inserted values, primary index. That's why I'm getting an incremental values. So it is doing some job. But we cannot verify unless we retrieve all the results to see whether what is inserted. Get same procedure. Transaction, maybe read only is enough for me, because I'm just going to see whether what is inserted inside. Here, where open the cursor. new method. Usually it contains two arguments. One being if you have any query conditions or any kind of index you are trying to insert. In this case, select star. So there is no where condition for me. So I can maybe I can keep it null. I don't have any specific. Just retrieve everything. Ascending, descending order if you have anything. So by default, it's a like kind of ascending order. By default, it will give you. If you really have something descending order, so previous. So the first one will be the last inserted one will be shown first, and then rest of the thing will appear. Now I prepare the request object. Now the same procedure, request, see whether it is success. It's not a function. So prepare the result object, event target result. Or maybe it is called cursor. So you have a cursor instance now. I need to verify the cursor is not empty. Time to iterate it. Cursor continue. This function, this if block, will keep on work until the entire cursor become null, and then execute and then exit. So time to see whether console log cursor. Cursor has an object called value. We'll see what is exactly inside this cursor. I'm going to need one more function button. Let me see if everything goes well. Should get get. Once I click get all record, if we see the individual objects which I inserted, of course the random subject something I inserted, which if you notice the primary key student ID automatically added. I did not add that particular object. If you notice this one, what is that insert where it is happening. So I did not even mention this std ID in this object. Of course, because it is an auto increment, automatically got added and gives me a unique identity for my record. And of course, these are all the value I randomly inserted. Every object could be retrieved. So maybe multiple times 32 object exist. So how I can retrieve it? Cursor.value.std name. Oh, sorry, std student name alone. If you would like to retrieve, you can get it. Of course, the same name is there. So that's why 32 times. Maybe std sub. These are all the values. So individual value could be retrieved and display wherever required. So we just created a simple database. Now we know how to create a database. If a new database, yes, proceed creating object stores and give the indexing capability to the fields of the object store. Object store is equivalent to a table. So when a table or object store is created and we are giving in defining inner fields. So in this case, std ID, std name, std subject, all the fields. I mean this one, this one, this one. So three different fields we are defining. In that one field is a primary key we have already defined, and another two fields are student name and student subject. I am also giving them an indexing capability and indexing identifier for it. For better utilization, I gave the same name of the field name so that I can directly use them. And I am defining they are either unique or not. Those things once we define, and now the object store is successfully created. And then you can do a transaction with the database. In this example, we simply did a insert statement equivalent. So we inserted a new object to my object store, To make that happen, I need to get the transaction object, defining how many object stores you are trying to access, what kind of access you need. Once you get the read or write permission or transaction object, and try to create a object store variable, object store object. So define the object store name. If you have more than one, define the single one which you are trying to access. In this case, probably you can even give this particular name as a student object store, because it's a student table, something like that, naming convention, or as you prefer. So once the object store instance is retrieved, you can do a transaction with that. This particular example is going to add something to the object store. So this has done, and I also made sure it is successfully added or not with the success object. I mean, the request parameter has a success object. And I also added one more function to retrieve all the data in the given object store, like select star from std table, no condition, because the open cursor object does not pass any condition to that. Of course, we can pass the condition, we can pass any condition, select star from student table, where what kind of condition you want, you can very well create it. And I'm giving a descending order. So maybe for your understanding. And when the request object is retrieved, I'm trying to see whether it has a values or not. Since it is a cursor, I need to check whether the cursor is not empty and execute until the cursor gets exhausted. A kind of iteration. The continue does the job. It's an object inside the cursor. So this block will work until the cursor goes to null. A kind of container you are taking one by one out, like that. So once you retrieve everything, the cursor become null, then it will exit the if block. So till the time the cursor is iterating and retrieving the value what is there inside the cursor. So we made sure the values are there inside this particular IndexedDB. So now somehow we are getting closer. Next task, I need to integrate this with the UI which I already created for a student record, which is having a local storage as a persistent engine. I want to replace it with this, and of course give the all edit, update, whatever feature along with this one. So once we are done, today's task of IndexedDB we are done. Then we will add a couple of other filters. We'll give a search bar so that the user type something and search. Generic search. User can type subject name or student name. Anything he types, it has to query the record and display the values. So like that, we will proceed and create a complex queries maybe tomorrow. I did slow down as much as possible. Even this particular block of code is a very small snippet. You can very well complete it maybe in 1 hour or 2 hours in the afternoon session. Spend time and see what is being really done. Okay, object store mean what, and transaction mean what, and try to play around with that. Try to change the version values to something and see what is happening and how it progresses. If anything unique you identify, you can also let me know. Okay, and what is the use of this DB object? Why I made it global? Identify it and see. Okay, make sure you finish that in the post-lunch session. Okay, do you really want me to proceed further, or stop here itself? The time is okay. Anyway, I'll do it in the afternoon session.